Okay, I'm on page 708. We are reviewing chapter 11. And today is the 5th. It's the 5th, right?
Yeah.
Okay, so page 708, and this is chapter 11. We're asked to solve quadratic equations. So let's say we want to solve 5. I'm sure most of these problems were done when we reviewed for test 3. So we are given z squared plus 3z plus 1 equals 0. We are asked to solve by completing the square. Let's work on this problem for 1 minute. And then we'll do it together. So we are solving by completing the square.
Is that Z?
Z, put x. If you don't like z, that's fine. So x squared plus 3x plus 1 equals 0. Can anyone give us the 4-step procedure?
Identify the middle coefficient, divide by 2,
Good.
square by 4, and add and subtract the
The middle coefficient is?
32. 30Z.
3Z.
3Z? That's wrong.
The middle coefficient, please.
3.
3. Divide 3 by 2. Let's square 3 over 2. Perfect. So we have z squared plus 3z plus 9 over 4 equals 9 over 4 minus 1. Because this has to be moved to the other side. Therefore, the left-hand side becomes very good. Indeed, 5 over 4, and inside here, c plus 3 halves. Very good. As we know, we cannot really solve a quadratic equation by completing the square, but now we have to take the square root from both sides, and we have z plus 3 halves equals. Very good. The top is, and the bottom is? Very good. So therefore, z equals negative 3 halves plus or minus the square root of 5 over 2. And we don't need to do anything else. Perfect. Okay, we are given the following formula. And this is problem 7 on the same page, 708. Okay, we have A equals P, parentheses 1 plus R squared. This formula is given to us, and we are told gives the amount A in an account paying interest rate R compounded annually after 2 years. So this is the 2 years. This is the principal. This is the accumulated amount. And R is the interest rate, annual interest rate. Okay, one more time. A is the accumulated value. P is the principal. R is the interest rate. 2 is number of years. So we are given, find interest rate R such that 25,000 increases to 27,717. So 2,500 increases to 2,717 in 2 years. Round the result to the nearest 100%. So now we have to identify which is the accumulated value and which one is the principal. Of course, this is the accumulated value, and this is the initial value or the principal, and we're asked to find the rate. So we will just plug them in. Can anyone dictate? And I'll put them in. Excellent. Very good. We want to solve this equation. Let's think about it for 1 minute. Can anyone give us the first step when you're ready? Absolutely. And I will not bother to divide, actually. I will just write this. I don't care about that number. Not just yet, anyway. Take the square root from both sides. So then 1 plus r equals, and I cannot forget something crucial. Good? Whatever. And finally, r is? Which of these two, because we are talking about an annual rate of interest rate, which of these two possibilities has to be disconsidered? -1 plus the square root or -1 minus the square root? Right. So I will say only r equals -1 plus the square root of 2717 over 2500. Indeed. Very good. So now with the graphing calculator, clear whatever you have, and you have -1 plus the square root of, in parentheses, 2717 divided by 2500, close the parenthesis, and press enter. So r appears to be point, it says one more time, round the result to the nearest 100%. So I will say, first of all, it's 4.2497%, but they want us to round it up to the 100th. So r equals 4.25%. Any questions? Any questions on this problem? Problem 8. 2 ships leave at a port at the same time and travel at the same speed. One ship is traveling north, the other one east. So north and east. Same rate, and they leave at the same time. Same speed, and they leave at the same time. In a few hours, the ships are 150 miles apart. How many miles has each ship traveled? Give an answer, exact answer, and an approximation with one decimal place. Yes. So let's think about this for a minute. Can anyone give us the starting point, and then I'll let you work on it for another minute. But can anyone tell us what to do? Nope. But we are told they start at the same time and they sail at the same speed. So how much is this? X. Okay, if you want to call it A, that's fine. Don't change the notation. Then what is this? But they start at the same time, right? This is the whole idea. They start at the same time and they drive or sail at the same speed. Otherwise, I will have two variables and I will not know what to do with them. So what will you write for this scenario then?
A squared plus A squared.
Very good. A squared plus A squared equals 150 squared, or if you use X, then it's X squared plus X squared 150 squared. Good, so let's solve for X or for A, whatever you want, it doesn't matter to me. Can anyone give us step 2? I have to. An apple plus an apple is 2 apples. 2A squared equals squared. And then I will divide both sides by 2. And then what? And then I have to do what to both sides to solve? Good. So then A will be plus or minus the square root of 150 squared over 2. However, A is a distance. So I will say only the square, exactly. The square root of 150 squared is 150, and the square root of 2 is the square root of 2. They wanted us to present the exact answer, but the exact answer is, what do I have to do to this quantity? From chapter 10, I know that I cannot leave it like this. What do I do to it? Right, I have to rationalize it by multiplying and dividing both top and bottom by. Very good. So then A equals 150, the square root of 2 over 2. And yes, I will simplify. Notice that I put 1 and I put 75. So A equals 75, the square root of 2. What was the measurement unit in miles? And now I also want to approximate. So I grab the calculator and I multiply 75 by the square root of 2. And what do I get? Yes, 106.06. Very good. So approximately 106.06 miles. I think it was 06, wasn't it? Yes.
I got it to 7.
Yes, I agree with you. 7. Okay, very good. Moving on. If the discriminant, I'm looking at 11, I'm looking at 9 through 12 on page 708. Problem 9. If the discriminant of a quadratic equation has the given value, determine the number and type of solutions. Okay? If the discriminant is negative 8, can anyone remind us what the discriminant is? B squared minus 4AC is the discriminant. What is under the square root in the quadratic formula? Okay, so now if the discriminant is negative 8, how many solutions on what type? 2. Imaginary, because I cannot take the square from negative 1. Imaginary solutions. Okay, problem 10. If the discriminant is 48, what can we conclude about the solutions? And how many? It's all about the quadratic function. Whether it touches the x-axis, it doesn't touch, or it crosses. That's all. So if the discriminant is 48, 2 real solutions. If the discriminant, that's problem 10 now, is 100, how many solutions and what type?
Isn't
It's the same.
the same as 2 real solutions?
So we can only have 1 real solution when it touches, 2 solutions when it crosses, and no solutions. When it doesn't touch, it doesn't cross, right? So 100 is still the same thing, 2 real solutions. And what happens in number 12 when the discriminant is 0? 1 real solution, indeed. Good. Okay, let's look at I would like to also look at problem 4. 5x minus 2, everything squared equals 2. Let's solve this equation. And can anyone in particular tell us, in particular, what method will you use to solve this? You have different ways, but which one is the most useful in this particular case? Of course. Of course. If you start by expanding that and moving to, it's going to take longer, and using quadratic formula, it's going to take much longer. This equation is already set up for taking square roots. Okay, the left-hand side would be correct. No.
Oh, plus or minus.
Good. Now what do I do next?
Move over -2.
Correct. So I have 5x equals 2 plus or minus the square root of 2. And finally?
2 plus or minus 2.
Perfect. Okay, here's another problem for you. Problem 18. 2x minus 3 squared equals x. Say it again.
Are you asking for what?
Well, I'm asking for solutions. Use the method you like. A method that is applicable in this situation, of course. I'm also in this room, and I didn't want to forget that, Tuesday. I'm in this room from 3 to 7 p.m. Write it down if you, Tuesday, December 13th. If Tuesday works better for you, I know our class is Monday, Wednesday, but if Tuesday works better for you, I'm in this room from 3 p.m. till 7 p.m. for your final exam. If not, I'm in this room on Wednesday from 3 p.m. till 7 p.m. Wednesday the 14th. Also, you have the option of Monday, December the 12th from 5 to 7 in this room. Up to you.
So Wednesday can be either 3 to 5 or 5 to 7.
Wednesday the 14th can be anywhere between 3 and 7 p.m. Tuesday, anytime between 3 and 7 p.m.
How, can you tell us how long the test is?
About 20 questions. Yeah.
Collected from the other exams.
From all of them, yes. Yes.
Because the ABC.
Okay, so one more time, Monday from 5 to 7 in this room. Tuesday next week from 3 to 7 in this room. And Wednesday next week from 3 to 7 in this room. Now, past Wednesday, I hope that that's not going to happen. If you don't show up for the final exam, I have to put in a 0. I only have 24 hours to put the final letter grades. Okay? So please remember between today and Wednesday next week evening. Okay. Good. So can anyone tell us how to solve this problem? First step, please.
Square root of both sides.
I cannot because one side is x. I cannot do that.
So I got x plus factor out into x minus 3. So it's like 4x squared minus 6x.
2 times 2 times 3.
Yeah. Sorry. That's 12. And then 9 equals.
Exactly. Only because one side is a variable. If it were a number, it would have been straightforward, taking square roots. But I can't take the square root when one side is a variable. I can only take a square root only when one side has the variable, not both. So then this becomes 4x squared minus 13x plus 9 equals 0. And now we want to solve this. So this was done because it was, I'm lying to you? No, I'm not. Okay. So this was done because this was the last test. This is what we are working on right now. And then we're going back to test 2 and then to test 1. Okay? So this is everything from test 3. Can anyone tell us how to proceed here? Yes. 2 numbers whose product is excellent and whose sum equals good. So let's think. Good. The product is 36. The sum is negative 13. Now the new equation becomes good. What procedure do I apply now? Yes, from the first two. So this is 4x minus 9. From the other two, good. And now I look. So the common factor is 4x minus 9, and then x minus 1. So there are two options. Can anyone give us those two options? Yes, but this is not a rational equation. So x has to be 1 or x, yes, 9 over 4, indeed. Very good. Okay. Problem 23. And you can say, what is this? This was in chapter 7. Yes, but this is chapter 11, and now these problems come into play again. Okay, 1 minute. First step, please. Good. 5 over x plus 6 over x minus 2 minus 3 equals 0. Two restrictions, please. Some of you forgot to write 0, and as I mentioned before, if you forget to write the right-hand side, you will never solve for anything. This is what I do so I don't forget. If I forget this side, I'm done. I will never solve for anything. So the least common denominator, the tops, very good. Right, I will write it already multiplied because for simplicity, for convenience actually. Good, so then can anyone dictate the top? Yes, I agree with 5x minus 10 plus 6x, I agree. I agree. Plus 6x indeed. Good. Look again, because if I forget this, I will never solve. The denominator is still x times x minus 2. And now the numerator in descending order, please. I agree with negative 3x squared. I have 6 plus 6 and plus 5. So 17x, good, and minus 10. Now I put it over 1. What do I do next? Indeed, so let's cross multiply. When I cross multiply, what do I get? Negative 3x squared plus 17x minus 10 equals 0. Good. Let's think about this. What will be the very first step you should perform? I recommend. Multiply both sides by? Yes. So this is 3x squared minus 17x plus 10 equals 0 is so much easier to solve. Okay, let's work on this for 1 minute. And I thank you guys, I forgot to mention, for very good grades. I can say that you really studied and everyone got a good grade. I'm very happy, very proud of you. Thank you. And I hope that this week you're gonna intensify your energy and your please and your commitment to the course so you can get a good grade on the final. Please. So do we know how to split this or not yet? Yes, so 3x squared minus 2x minus 15x plus 10 equals 0. And now, good, what is left? And what is left from the other two? Look what I did. I wrote the equal symbol and 0 because if I forget this, I will not solve. I cannot stress enough. So what do I have here? Very good. I agree with negative 5. So then 3x minus 2 and x minus 5. And I have the options. The options are? That's it. First thought I have, because this is so long and I had so many steps, but I can't forget to check against the restrictions. Is 2/3 here? No. Is 5 here? No. So these must be the correct solutions. Okay, perfect. Okay, let's look at problem 24 now. Same page. In 24, we have x to the 4th minus 21x squared minus 100 equals 0. How many solutions will this equation have? 4. The degree is 4. 4 solutions. Excellent. 1 minute. Can anyone get us started? Just started. Yes. So we'll say let T be good. So that's the starting point. Good? 1 minute. Can anyone give us the equation we need to solve?
T minus 25 T plus 4 equals 0.
Okay, so first of all, it's t squared minus 21t minus 100. And yes, now we have to factor this completely. I agree. And yes, you said t minus 25 and t plus 4. I agree with both. And then t equals 25 and t equals negative 4. We agree so far? But now this is an equation, and this is a different equation. What equation is this? This is t equals 25. I take the square root. X equals plus or minus 5. X squared equals negative 4. I take the square root. That's the easiest method to apply here. X equals? Very good. Plus or minus 2i. Excellent. Good. Next problem, 25. If you have questions, stop me, please. X to 2/3 minus 6x to 1/3 and then plus 5 equals 0. Can anyone get us started? Just the starting point. Let t be x to 1/3. Good, 1 minute.